కనిపిస్తుంది సార్.
Okay. Capacitor actually stores electrical energy. It stores electrical energy. Now you place two plates. Okay, this is a parallel plate capacitor. Now I connect this to the positive terminal of the battery, and this I connect to the negative terminal of the battery.
Yes,
If
sir.
I connect it to the positive terminal of the battery, then what happens here? This acquires positive charge.
Yes, sir.
If this acquires positive charge, then it will attract the negative charge.
Yes, sir.
Then the positive charge here goes to here.
Yes, sir.
Okay, goes to the negative terminal. Okay, so now here there is an electric field here.
Yes, sir.
Okay, so this is plus Q, and then this is minus Q.
Q. Yes,
Symbol of the capacitor is like this, or else in some books it will be like this.
yes, sir.
Okay. Now let us see how to calculate or how you got this value. What is the value of the capacitance? Now here you can see if this acquires positive charge and this acquires negative charge. Okay, now the potential difference is V.
Yes,
Okay,
sir.
charge is plus Q and charge is minus Q.
Minus Q.
Now the potential difference, the potential difference is V. V is equal to ED,
Yes, sir.
electric field, into distance between the
Distance.
two plates.
Yes,
Okay,
sir.
that is D. Okay, V is equal to ED.
ED.
Now we know that electric field between the plates is sigma by epsilon naught.
Yes, sir.
Sigma by epsilon naught. How you
Epsilon.
got sigma by epsilon naught? Now here if you got a plate, and now infinite plane of charge, here it is sigma by 2 epsilon naught,
Yes, sir.
right? Electric field is in this direction. Let us take this as E1.
E1.
Okay.
Yes,
Now
sir.
this is minus. So this also attracts in this direction. E1,
Yes,
which
sir.
is also sigma by 2 epsilon naught.
2 epsilon
So
naught.
sigma by 2 epsilon naught plus
Sigma
sigma
by
by 2
2 epsilon
epsilon
naught.
naught. That is 2 sigma by 2
2
epsilon naught. 2
epsilon.
2 gets cancelled. Sigma by
Sigma by epsilon naught.
epsilon naught is
Yes.
electric field E. Okay,
Yes,
so
sir.
E is equal to sigma by
Epsilon naught.
epsilon naught. Okay, so sigma is nothing but a Q by A,
Yes, sir.
surface charge density.
Yes, yes,
Q
sir.
by A
A
epsilon naught
epsilon.
is E. So
Yes,
now
sir.
you calculate V. V is equal to ED. V is equal to ED. That is equal to
Q by
Q by
A epsilon into
A
D.
epsilon naught into D.
D.
Now
Yes, sir.
C is equal to Q by V.
V. Yes, sir.
So that is QD by
By
Q by
Q by A
QD
epsilon.
QDA epsilon naught. So
Epsilon
this
naught.
Q gets cancelled. You will get A epsilon naught
Epsilon
by
by
D.
D. Yes, sir.
So C is equal to A epsilon naught by D. The
D.
capacitance is equal to A epsilon naught by D. What we did? V is equal to ED. We
ED.
just substituted sigma by epsilon naught.
Epsilon.
So
Yes, sir.
we calculated QD by A epsilon naught. We substituted C is equal to Q by V. You'll get C is equal to A epsilon naught by D.
D.
Okay.
Yes, sir.
Now here, see, if one of the plate is bigger, and one of the plate is smaller. Let us take this is A1, this is A2. The distance between them is D. Then the capacitance of this is equal to epsilon naught A2 by D.
D.
Whichever is
Yes,
smaller,
sir.
that one we need to take.
Yes,
Okay.
sir.
Yeah. Now, right. So this is
Yes, sir.
for parallel plate capacitor. Okay.
Yes, sir.
Now for parallel plate capacitor, next one is a spherical capacitor. Next we will discuss about spherical capacitor. Spherical capacitor. Spherical capacitor. The name itself indicates that you have here you
Spherical.
have A, radius A, and another bigger sphere. Okay, now that radius is B, then the capacitance is equal to 4 pi epsilon naught AB by B minus A, that
A.
is spherical capacitance. Okay, now next one is cylindrical cylindrical capacitor. In cylindrical capacitor, you will have two capacity. This is one. Okay. Now,
Yes, sir.
and this is another one. Okay.
Yes, sir.
Let us take this as A and that as B.
D. Yes, sir.
Then C is equal to 2 pi epsilon naught L by log B by A
Yes, sir.
base E. And this is the cylindrical capacitor.
Yes, sir.
Okay.
Yes, sir.
Now for parallel capacitor, it is epsilon naught A by D.
A by D. Yes, sir.
Okay. Now we'll discuss something about polarization. Okay.
Yes.
Next concept is what you call as polarization. Polarization. Okay. Now here, what happens here is this is positive plate. This is
Yes, sir.
negative plate. And you keep a dielectric in between. Okay.
Yes, sir.
We place a dielectric in between. When we place a dielectric here, it develops negative charge.
Yes, sir.
This negative will create positive charge here.
Yes, sir.
Now, if the dielectric is not placed, let us take that electric field is E and it is in this direction.
Yes, sir.
Okay. Now, after placing this dielectric produces electric field in opposite direction. Let
Yes,
us take this as induced. Okay.
yes,
Now the net
yes, sir.
electric field E net is equal to E minus EI.
I.
Okay.
Yes,
The
sir.
net. So what happened when you place dielectric? The electric field decreases. Electric field between the charges gets decreased, and
Yes, sir.
this E by EI is K, dielectric constant.
Yes, sir.
Dielectric
Constant.
constant. Okay, this is also called as a relative permeability or permittivity.
Yes, sir.
Relative permittivity. Epsilon R. This is also called as epsilon R.
Yes, sir.
Okay, right. Now we will discuss this one. When this is completely filled, when the dielectric is completely filled, then the capacitance is, then the capacitance is K epsilon naught A by D.
D. Yes, sir.
When the dielectric is completely filled,
Yes, sir.
filled between the plates, then you will
Yes,
have
sir.
K epsilon naught A by D.
D.
Okay. Now,
Yes, sir.
I will discuss the effect of dielectric when the battery is placed and the battery is disconnected. Okay. Like
Yes,
a
sir.
tabular form, I will write this is battery removed, and this is battery remains connected. Battery
Remained connected.
remains connected.
Yes, sir.
Okay, so these two things we will discuss. Okay, so the first one is capacity. Capacity. What happens to the capacity when the battery is removed? I mean, what I'm doing is I'm placing the dielectric. I'm placing the dielectric between the plates and battery is removed. Okay,
Yes, sir.
when the battery is removed, what happens to the capacity? What happens to the capacity? We already discussed the capacitance increases K times. Here
Yes, sir.
also, battery remains connected. I mean, I place dielectric and battery remains connected. Okay, like this. Now here also, the capacitance is equal to Kc.
Case.
Okay. Now,
Yes, sir.
see, charge. Here, battery is removed. Battery is removed, but whatever is the charge here, the charge will always
Remained
stay
same.
remain same. So the charge
Yes, sir.
remains same. Charge remains same because this is conservation of charge.
Yes, sir.
R- Charge remains same. Now here, when
Same.
the battery remains connected, then
Yes,
what happens? The charge increases k times. Why it
K times. Yes,
increases
sir.
k times? Look here, what is going to happen? Okay. Now here I place the dielectric. This is positive. This is
Yes, sir.
negative. It will have electric field in this direction. This is
Yes, sir.
E, and it will induce opposite charges. So electric field EI is in opposite direction.
Sir.
Already I told you that the net electric field will decrease because the electric field is in opposite direction,
Yes,
right?
sir.
But when you have connected to a cell, it will try to create the same potential. Now the potential
Yes, sir.
is E minus EI into D. See, the distance
Yes,
is
sir.
constant, but the electric field got decreased. As electric
Yes,
field got decreased, to increase the electric field, to increase this E value, what it does is the battery supplies the charge.
yes, sir.
The battery will supply charge to increase the E.
Electric field. Yes, sir.
To increase the electric field, it will supply the charge because the
Yes.
electric field is equal to sigma by epsilon naught,
Epsilon naught.
right?
Yes, sir.
So Q
Yes, sir.
by A epsilon naught. So if Q is increased, okay, because battery will supply charge. Okay.
Yes, sir.
Now here potential, see what happens to the potential. Now the potential here will become how much it will become. See, as the electric field gets decreased, here electric field in this direction, that is induced electric field
Yes,
in
sir.
this direction. Electric field got decreased and you cannot increase the electric field here. So electric field got decreased. So the potential will get decreased because distance D is constant. So
Yes.
potential will get decreased.
So even if battery is removed, induced current will flow, sir.
Now, if battery is removed, but here you have charges, na? This charge will induce
Yes.
negative charge here. This negative charge will induce positive here. So you
Yes,
will
sir.
have electric field in opposite direction.
Right.
Here,
Yes.
yeah, electric field will decrease. Okay, there is
Yes, sir.
no, okay.
Yes,
Electric
sir.
field decrease. As electric field got decreased, potential
Yes, sir.
will decrease.
Potential will decrease. Yes, sir.
Okay, here what happens here, as you have connected to battery, battery maintains constant potential difference. So V
Yes,
dash
sir.
is equal to V.
Constant V. Yes, sir.
Okay, because it provides constant potential difference.
Yes, sir.
Then what about the field, electric field? Now, now the electric field E dash will
Decrease.
become E by K. It decreases.
Yes, sir.
Here electric field, what happens to the electric field? It remains same because you are
Same.
the battery will provide charge such that electric field will become same.
Constant. Yes, sir.
Yeah. And what about energy? Energy.
Yes, sir.
Now here this is energy is U dash is equal to here half C V square,
Yes, sir.
half C half
V.
C dash V dash square, that is equal to half C dash is Kc, V dash is V
V
square
by
by
K.
K square, that is equal to
Yes.
half CV square by K, that is equal
K.
to U by K.
K. Yes, sir.
Okay. Now here energy is U dash is equal to I will use the same formula, half C dash, half C dash V dash square is U by K.
K. Yes, sir.
Okay. Now here what we can use here half C dash V dash square, half C dash V dash square, that is equal to half into Kc into V dash is V square. So it becomes K times of U.
U. Yes, sir.
Okay. So,
Yes, sir.
right. Understood up to here?
Yes, yes, sir.
Okay. Right. Okay. If nothing is said, it is assumed that the battery is disconnected. Okay.
Yes, sir. Yes, sir.
If not given, then we will assume that battery is
Disconnected.
disconnected. Okay. Then
Yes, sir.
we have to write this one and then you have to understand what is the process going on.
Yes,
Okay,
sir.
I'll be writing couple of tables, so you may get confused. So you have to understand why I'm really writing those points, why we are having that value. Logic you have to understand, okay?
Yes,
Logic is
yes,
there, then it is very easy to remember.
yes, sir.
Without logic, then it will become difficult, okay?
Yes, sir.
Right. Now, next one is when dielectric is partially filled between the plates. When dielectric is partially filled between the plates. Okay, now you see this one. This is a plate. So this is positive plate.
Yes,
Okay.
sir.
And this is negative plate. And I'm placing a dielectric here. Let us draw the dielectric with another color.
Yes,
Now that is the dielectric. Okay.
yes, sir.
So now, as usual, what is the electric field? This electric field is in this direction.
Yes, sir.
This negative will induce positive.
Positive.
This positive will induce
Negative.
negative. So this electric
In the
field is in this
opposite
electric
direction.
induced is in this direction.
Yes, sir.
Now this distance is
Distance.
d. Okay.
Yes, sir.
Now this thickness of this dielectric is t.
Yes, sir.
Okay. So now we know that electric field got reduced.
Yes,
Okay.
sir.
Now my intention is to get a v dash value. What is the
Yes,
potential? Okay.
yes, sir.
Now potential v dash is equal to, now the electric field is E. E here E into d minus
To
t.
D. Yes, sir.
E into d minus t plus, now electric field will get reduced by k. E
E
dash
by K.
is, or EI is E by k into
Yes, sir.
t.
Yes, sir.
Into t. That is the total potential V dash.
Yes,
Okay,
sir.
so here I will write V dash is equal to E into d minus t plus t by
E
k.
by K. Yes, sir.
Okay, so
Yes, sir.
E is equal to sigma by epsilon
Sigma
naught
by epsilon naught.
d minus
T
t
minus T
plus
plus
t by
T by
k.
K. K.
That is equal to q by a epsilon naught.
Q
Okay, sigma is equal to q by a
by A
d minus t plus t by
plus K.
k. So
Yes, sir.
capacitance C is equal to q by v dash, that is equal to q by v dash is q
Q
by
by
a epsilon naught
epsilon
d
D
minus
minus
t plus
plus
t by
T by
k.
K.
This
Q
gets
gets cancelled.
cancelled. A epsilon naught by d minus t plus
Plus T by
t
K.
by k is C.
Yes, sir.
That's the capacitance.
Yes, sir.
If it is partially filled, d minus t plus
T by
k,
K.
t by k.
K.
Okay.
Yes, sir.
So now what I'll do is, here I'll take the the positive charge, and here I will take negative charge,
Yes,
and
sir.
here I will write, here I will put couple of dielectrics.
Yes, sir.
Few dielectrics I'll place here. Now I will write capacitance C is equal to capacitance C is equal to epsilon naught A. Now if that A is the area of the plate,
Yes,
okay,
sir.
by d is a distance
Yes, sir.
minus t1 plus t2 plus so on plus tn.
TN. Yes, sir.
Okay, like that n are there. Okay, plus
Yes, sir.
t1 by k1 plus t2 by
T2 by K.
k2 plus so
K2.
on plus
TN
tn
by
by
KN.
kn.
KN. Yes, sir.
Okay, we just extend d minus t1 plus t2 like that, plus tn
Yes, sir.
plus t1 by k1 plus t2 by k2 plus so on plus t1 by k1. Okay.
Yes. Yes, sir.
Now, another one is, now what if you have a positive charge here? Okay, positive charge here, plate here, and a negative plate here.
Yes,
Okay,
sir.
and 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 this one is one dielectric, and you have this one another dielectric,
Yes, sir.
this another dielectric, another dielectric like this. Okay,
Yes, sir.
K1, K2,
K, K,
K3 and K4
K.
completely filled. If it is
Yes,
completely filled, C is equal to epsilon naught A by,
sir.
now here D and T both are equal because the thickness
Yes,
T1 plus T2 plus T3 plus T4 is equal to D. So T
yes, sir.
minus D will become 0. So you will
Yes, sir.
get T1 by K1
By K1
plus
plus T2 by
T2
K2.
by K2 plus
So
T3 by
T3 by
K3
K,
plus T4
T4 by
by
K,
K4.
K4. Yes, sir.
Understood?
Yes, sir.
When this is partially filled.
Yes, sir.
Okay.
Yes, sir.
All right. Now taking further, sometimes we will say, okay, metal plate is filled.
Yes, sir.
Okay. Metal plate is placed. So you will say, okay, this is one plate, this is another plate, and it is filled half of it with a metal plate.
Yes, sir.
Now you have to understand that whenever metal plate is placed, this K value for the metal plate is infinity if this is metal. If it is not a
Yes, sir.
dielectric and if it is a metal, then K is infinity. Then if you
Infinity.
substitute in the formula epsilon naught A by D minus, here
D.
T is D by 2.
Yes, sir.
T is D by
D by
2 plus T by K.
2 by K. Yes, sir.
T by K, but you know that K value is infinity.
Infinity.
Okay. Now
Yes, sir.
here the question is, metal is placed, metal is placed, whose thickness is equal to D by
By
2.
2.
So that's
Yes, sir.
why I placed in place of T D by 2. Okay. Now this K value is infinity. So if this is infinity, this term is going to be 0.
0. Yes, sir.
So this is epsilon naught A by D
D.
here. D
Yes,
minus
sir.
D by 2 is D by 2. 2 goes up. So C is equal to 2 epsilon naught A by D.
D. Yes, sir.
Okay. Now, sir,
Yes,
if that is not half filled, if it is completely filled, then what is going to happen? So this is positive. That is going to be negative. And if I just fill it up with some metal, K value is infinity, then
D.
C is equal to epsilon naught
Epsilon naught
A
by
by D minus D, is D minus D is 0, and
yes,
T
sir.
by K is infinity. So this
Infinity.
term is also 0.
0.
So the capacitance is equal to
0.
0.
Yes, sir.
No, infinity. Okay, 1 by 0, infinity. Capacitance is
Infinity.
infinity. Now, If not, if it is given like this also, it is infinity. Say this is then we say this is short circuited. Okay,
Yes, sir.
this is minus. Then you connect like this. Then also we say C is infinity.
Infinity.
Okay,
Yes, sir.
because this we say short circuit.
Short. Yes, sir.
Okay.
Yes, sir.
So this is when metal slab is placed in between the when this is when metal slab is placed. When the metal slab is placed, then these are the concepts
Yes,
we
sir.
need to remember. Okay,
Yes, sir.
right. Next point is when the separation between the plates is increased or decreased. When separation between the plates is increased or decreased. When the separation between the plates are increased or decreased, then what happens? C is inversely proportional to D. So
Yes,
if
sir.
the distance between them increases, then capacitance decreases.
Decreases.
Okay,
Yes, sir.
right. So now if the other variables are all constant or the battery is disconnected, okay, right?
Yes, sir.
Now, so when now I am going to discuss separation is increasing. Say when the separation is increasing, separation is increasing, what will happen?
Yes, sir.
Say when the separation is increasing, I will draw a table again. Okay. So first I will write battery removed. We'll check the conditions here. Battery removed. And this is battery remains connected.
Yes, sir.
Battery remains
Connected.
connected.
Yes, sir.
Let's see what is going to happen. Now capacity. Now, what happens to the capacity? So these are two parallel plates. The distance between them is D.
Yes, sir.
So C is
Proportional to D.
inversely proportional to D.
Yes,
So
sir.
C dash is less than C.
C.
Okay. When the battery is connected, then also C dash is less than C.
C. Yes, sir.
This is about the capacity. Okay. Then I will come to charge.
Yes, sir.
What happens to the charge if the battery is removed? Battery is not connected, then the charge remains same. So
Constant.
you get Q dash is
That
equal to Q.
Q. Yes, sir.
O- Okay.
Yes, sir.
Now here battery remains connected, then Q dash will be less than Q. Okay, because when you
Yes,
are when you are moving, when the distance between them is increasing,
Yes, sir.
when it is increasing, V is equal to E into
Into
D.
D.
Then
Yes,
if
sir.
D is increasing, if D is increasing, potential will increase.
Increase.
But
Yes,
when
sir.
you connect it to battery, it should have same potential as that of battery.
Yes, sir.
So what happens here is it decreases the charge here. So the charge will move into the battery.
Yes, sir.
So when you connect it to the battery and you move the capacitor away, then the
Yes, sir.
charge will move into the
To the battery
battery and the charge will decrease on the plates, so that
capacity.
the potential between the capacitor and the battery remains same.
Yes, sir.
Okay. Then what about the potential difference? Potential difference. What happens to potential difference? Potential difference. Potential difference when D increases, then potential is going to increase here. Whereas here potential is going to remain same because
Remain
battery
constant.
supplies constant potential. Here why the
Yes,
potential is increasing? The potential is increasing because V is equal to E into D. When D
yes.
increases, then potential increases.
Increases. Yes, sir.
Right. Next one is electric field. What happens to electric field? The electric field remains same because the charge will remain same. So the electric field will remain same.
Same. Yes, sir.
Okay. Now here E dash will be less than E. Why it will be less than E? Because the charge has got reduced.
Yes, sir.
When
Moved into
charge
the
got
battery.
reduced, E is equal to sigma by epsilon naught. So electric field also gets
Reduced.
reduced. Okay. Then we will discuss about the energy. Energy U is equal to q square by 2c. Now what is happening to charge is constant. Charge is constant. When D increases, then capacitance decreases.
Decreases.
When capacitance decreases, U increases.
Increases. Yes, sir.
So U increases. Now here U is equal to here V is constant, so I will write a half CV square. Here Q
V
is
square.
constant, so that's why I wrote Q square by
V
2C.
by 2C.
Now here potential is constant. Capacitance, what is happening to capacitance? Capacitance
Decreases.
got decreased.
Decreases.
So the energy gets decreased.
Decreases. Yes, sir.
Okay.
Yes, sir.
So this is separation is increasing. Now I will write separation is decreasing. Okay.
Yes, sir.
Separation is decreasing.
Sir.
When the separation decreases, what happens when separation decreases? So here
Battery
battery
disconnected.
removed.
Yes.
This is battery
Remains.
remains connected.
Same. Yes, sir.
Battery removed. So The first one we'll talk about is capacity.
Yes, sir.
Okay, now what about the capacity? Now what we were doing, battery removed, and you're decreasing the D.
Yes, sir.
C is inversely proportional to D. What happens?
Yes, sir.
When D is decreasing,
Increasing.
when D is decreasing, C value
Increases.
increases, obviously. So
Yes,
C dash is greater than
greater than
C.
C. C. Yes, sir.
C. Okay, now here also the same thing happens. C dash is greater than C because
D.
C is
Yes.
inversely proportional to D.
Proportional to D. Yes, sir.
Okay, second thing. Okay, so now what we are going to discuss now here is uh, charge.
Yes, sir.
Now the charge battery is removed, the charge is conserved, charge remains same. When the battery is
Yes,
not there, Q
yes,
dash
sir.
is
Q dash
equal
is
to
equal to Q.
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 Now here, what happens here?
Charge is
Because
moved.
capacity got
Yes,
increased means now it can store more electrical charge. That means
yes, sir.
charge increased. Charge
Yes, sir.
increase. That means Q dash is
Q
greater
dash is
than Q.
greater than Q. Yes, sir.
That means the battery has supplied charge.
Yes, sir.
Okay, because
Yes,
now
sir.
here when you say the capacitance got increased means the ability to
Charges
hold
got
the charge, the ability to hold the
increased.
charge got increased.
Increase. Yes, sir.
Okay, now what about the
Potential.
potential? Potential difference. What about the potential difference? V is inversely proportional to V is inversely proportional to C. V is equal to Q by C, right? But Q is
Yes, sir.
same, so V is inversely proportional to C.
Proportional to
C
C.
increases, then potential
Decreases.
decreases. Then V
Yes,
dash
sir. V
is
dash
less
less
than
than
V.
V. Yes, sir.
Okay.
Yes, sir.
Now, what about here? Here it is connected to battery. Whenever you connect to battery, V dash will be equal to V.
Same. Yes, sir.
It remains same,
Constant.
constant. Okay, then potential difference, then we'll talk about electric field.
Energy. Electric.
Electric field. What about electric field? Electric field E dash is equal to E as long as
Yes.
charge remains same. Q
Electric
by,
field in.
yeah, because it is sigma by epsilon naught. Sigma is nothing but Q by A.
Yes, sir.
So electric field remains same.
Same.
Here charge
Electric field.
increased.
Yes.
So electric field also
Electric field increases.
increases.
Yes, sir.
Now here what we write here, electric field, then energy.
Yes, sir.
Energy is now here Q is there, so I will write Q square by 2C. Q
Yes,
square
sir.
by 2C. That means the capacitance has got increased, so U will decrease.
Decrease.
So U dash will decrease. U
Dash is
dash is less
less than
than
U.
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 Now
Yes,
what
sir.
about here? This potential is same, so I will write U is equal to half
Half C square.
CV square. Now the C dash has got increased,
Yes,
so
sir.
U dash will also get
Increase.
increased.
Yes, sir.
So U dash will get
Greater
increased.
than.
U
Yes,
dash
sir.
is greater than U.
U. Yes, sir.
Okay,
Yes, sir.
right. That's the separation when the separation is decreasing.
Decrease. Yes, sir.
Okay, right. These are all problems we are discussing in terms of concept. Okay.
Yes, sir.
Okay, right. Next point is force between the plates of a parallel plate capacitor. Okay, force between the plates of a parallel plate
Capacitor.
capacitor. Force between the plates of a
Parallel.
parallel plate capacitor.
Yes, sir.
So you have a parallel plate capacitor. Okay.
Yes, sir.
Now this is having positive charge. This is having negative charge.
Yes, sir.
Now this produces electric field. Okay.
Yes, sir.
This produces electric field. In
Yes,
this field, this charge experience some force.
yes,
So
sir.
F is equal to Q into E.
Yes, sir.
So Q into this E is what, sigma by 2 epsilon naught,
By
because
2
this is electric field due to one plate only.
Yes, sir.
So that is equal to Q into sigma is Q by A.
IA.
Here 2
Yes,
is there, the 2 I wrote here. Okay. So
yes, sir.
Q into Q will get
Q square.
Q square by 2A
2A. Epsilon naught.
epsilon naught.
Yes, sir.
So that this is the formula for force. The
Yes,
force on a parallel plate capacitor is equal to Q square by
2A epsilon
2A
naught.
epsilon naught,
Yes, sir.
as F is equal to QE.
Yes, sir.
Okay. Now
Yes, sir.
here force, this is force. Okay. Now energy density between the plates of a parallel plate capacitor. Energy density. Okay, this is force between the plates of a parallel plate capacitor.
Yes,
Next
sir.
one is energy density. Energy density between the plates of a between the plates of a
Capacitor.
parallel plate capacitor.
Yes, sir.
Now here this is one positive plate
Yes, sir.
and this is another
Negative.
negative, this is negative plate.
Yes, sir.
Okay. Now between this energy density I need to calculate. Okay.
Yes, sir.
So energy density is equal to energy density is equal to energy by volume.
Yes, sir.
Energy by volume.
Volume.
Now what is the energy? Energy is half CV square
Half C. Yes, sir. Yes, sir.
by volume. Volume is area into D is volume,
20. Yes, sir.
right? Half into C is epsilon naught A by D
D.
capacitance
Yes, sir.
into V square into
Yes, sir.
V square by
A
A
into D.
into T.
Yes, sir.
Okay. Now we can write this A and A this cancel.
Yes, sir.
So you get half
Epsilon
into epsilon naught into V square by D
by
square.
D square.
Half epsilon naught V by D is E. Half
Yes, sir.
epsilon naught
Yes,
E square.
D square. Yes, sir.
Energy density is half epsilon naught
Epsilon E square.
E square.
Yes, sir.
Okay.
Yes, sir.
So this is another concept. Next concept is grouping of capacitors.
Yes, sir.
Grouping of capacitors. Now we have two groupings. One is series grouping. The other one is
Parallel grouping.
parallel grouping.
Grouping. Yes, sir.
Now in series grouping, you have charges like this, one after
Yes,
the
sir.
other. The capacitors were connected one after the other. Okay, now what you do is you give a positive charge here. Okay,
Yes, sir.
because that is connected to a positive terminal. Okay,
Yes, sir.
now let's see what happens here. If you have a positive charge, then it attracts negative charge here.
Yes, sir.
So now here it is attracting, this positive is attracting negative. That means it is repelling positive. So the positive will be here only, na?
Yes, sir.
So how much positive charge here you have? This is minus Q. This is
Yes, sir.
minus Q, then this is plus Q. If
Plus
this is
Q.
plus Q, this is
Minus
minus
Q.
Q. Then it attracts all negative here. So if it
Negative
is
charge.
negative
Yes,
here, it will push the positive, repel the positive. So the positive will come here. So this will become
yes,
Q. So
yes,
here it will become minus Q. So in series, whatever might be the capacitance might be different. C1, C2,
yes,
C3.
sir.
But the charge will be same. In series,
Yes, sir.
charge is same.
Same.
In series, charge is same.
Same. Yes, sir.
Okay, and the
Yes.
potential here is V, which is equal to V1, V2,
V2.
and
V.
V3.
V3.
So here uh, another point I will write. V is equal to V1 plus V2 plus
V3.
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 Okay. Now
Yes, sir.
the equivalent capacity will become see here V is equal to V1 plus V2 plus V3. V is equal to Q by C
Q by C.
is equal to
Q1.
Q by C1
C1.
plus
Yes, sir. Q by
Q2 by
C2.
C2 plus Q by C3. So
C3.
Q gets cancelled because I said the charge is
Charge is same.
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 So you
Yes,
get
sir.
1 by C is equal to 1 by C effective. That means if I remove these three and place a single capacitor, that capacitor is C effective.
1 by
1 by
C1.
C1 plus 1
1
by
by
C2
C2.
plus
1
1
by
by
C3.
C3.
Yes.
Now parallel grouping, let's come to this parallel grouping. Parallel grouping have one capacitor, you have another capacitor connected like this.
Yes, sir.
Have one connected like this. This all were connected here. Okay,
Yes, sir.
and then they were connected to positive terminal of the battery and then negative terminal of the battery. Now here this is plus
Plus
Q1
Q
and this is
minus Q
minus Q1. This is plus
plus Q1
Q2 minus
minus Q
Q2 plus Q3
minus
minus
Q
Q3. Now here
Q2.
charges are different, but the potential will be same
Same.
because
Yes, sir.
capacitance is C1, C2
C2,
and C3.
C3.
V is same.
Yes,
Okay,
sir.
and charge will be Q is equal to Q1 plus
Q2
Q2
plus Q3.
plus Q3.
Yes, sir.
Okay, Q
Yes,
is
sir.
equal to CV, right?
Yes, sir.
So C
Q.
effective into V, Q is the total charge. Okay, C
Yes,
effective
sir.
into V is equal to C1V
C1 plus
plus
C2.
C2V plus C3V.
C3V. V.
So C effective is equal to
C1
so C
plus
effective is equal to C1
C1.
plus
C2 plus
C2
C3.
plus C3. Okay, plus so on.
Yes,
If
sir.
more are there, plus so on, plus Cn we can
Yes,
write.
sir. Yes,
Okay,
sir.
now here I will write this C effective is equal to, if two are there, C1 C2 by C1
C1 plus
plus C2.
C2.
If only two are there.
Yes, sir.
Okay, now three are there, then C1 C2 C3 by C1 C2 plus C2
Yes,
C3
sir.
plus C3 C1.
Yes,
If two
sir.
are there, C1 C2 by C1 plus C2.
1 plus C2.
Okay, now here
Yes,
we just write C effective if only two are there, C1
C1 plus
plus
C2.
C2.
C2. Yes, sir.
If only two capacitors are there, if only two capacitors are
Two.
there, then only. Okay,
Yes, sir.
then you see another one important one is what is the potential if two are there? If only two are there, then what is potential? I mean, say for example, if you are having two capacitors and a battery. Now this is V1, this is V2,
V2.
this is V.
Yes, sir.
Okay, then what is the value I'm going to get? I mean, what is V1 value? V1 will be equal to C1 by C1 plus C2 into V. V is
Yes,
this. Okay.
yes, sir.
Then
Yes, sir.
V2 will be equal to C2 by
C1 plus C2
C1 plus
into
C2 into V.
V. Yes, sir.
Now for this one,
V is constant.
yeah,
V is constant.
V is constant. Now for here we'll write Q1 is equal to
Yes, sir.
Q1 is equal to C1 by C1 plus
Uh,
C2 into Q
yes, sir.
into Q. So Q2 is equal to C2
C2
by
by C1 plus
C1
C2
plus
into
C2 into Q.
Q. Yes, sir.
Okay.
Yes, sir.
Now if we n identical or connected, C effective is equal to identical.
Yes, sir.
Identical. Okay. Identical were connected, then C equivalent will be equal to C by N.
N. Yes, sir.
If these were identical,
NC.
then C equivalent is equal to NC.
NC. Yes, sir.
Okay.
Yes, sir.
Right. Next one. Let's see here one problem how to calculate the equivalent capacitance. Say, for example, this is 3 microfarad. This is 3 microfarad, and this is some 6 microfarad, and
Yes,
and here you have 3 microfarad, and here you are asked to calculate what is the capacitance between A and B.
B. Yes, sir.
Then first you calculate the effective capacitance of these two. These two are in series because if
Yes.
after this it is connected like this. So these two are in series. So effective series C effective is equal to C1 C2 by C1
C1 plus
plus 2. So 3 6 are 18 by 9. 18 by 9 is
2.
2
Yes.
microfarad. So this is 2 microfarad. Okay, now replace this one with 2 microfarad. This is 3 microfarad. Now this 2
Yes, sir.
microfarad and 3 microfarad are in parallel.
Parallel.
So
Yes,
when
sir.
they are in parallel, then C effective is equal to C1 plus C2. So that is 2 microfarad plus
Plus
3
microfarad.
microfarad, that is equal to
5
5 microfarad.
microfarad. Yes, sir.
Okay.
Yes,
Now
sir.
Now see this one, important model.
Yes, sir.
Now this is connected by a wire. The wire is connected like this. Now let us take this as A,
Yes, sir.
this as B. Now this is connected to this point. That means the potential when you connect with a wire, the potentials will be same. So this is A. So this is also A.
A.
So if
Yes,
this
sir.
is B, this is also B.
B.
Now
Yes, sir.
here the capacitance is given as C, C and
C.
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 Now
Yes,
you
sir.
see. Now I want the potential difference between A and B. So you write A here, B here. Now A to B, one capacitor is there. So you write like this, one capacitor, its capacitance is C. Now B to A, one capacitor is there, B to A, B to A, one
Yes,
capacitor is there. And then
yes, sir.
again A to B, one capacitor is there, A to B, one capacitor is there, right?
Yes, sir.
So this is C, C, C. So this is 3C.
3C.
C
Yes,
effective
sir.
is equal to
3C.
3C. These are all
Yes.
in parallel.
Parallel. Yes, sir.
Okay. Now you have one question, previous NEET, like this. C, C. Next. Okay. Now
Yes.
if this is A, then this point is also A because it's connected by a wire. This point is also A connected by a wire. Then A to B, A to B, A to B,
Yes.
C is there. So C. Then A to A. A to A means you can remove that one because this potential is same. This potential difference is same means you need not connect. When the
Yes.
potential difference is same, then there is nothing in
Yes.
between. Okay, potential
Yes.
difference is same. So A to B, A to B.
Yes, sir.
So we get 2C.
Parallel. 2C.
Yeah, I think
Yes.
similar model is there. I think this
Yes.
one, uh, this one, or maybe this one. I think NEET, previous NEET. Yeah, I'm pretty sure this is the one. I think this is the problem he gave in previous NEET.
Yes, sir.
No, that's B. That's A.
A.
This is C. This is C. This is C, and this is also C.
C. Yes,
Now,
sir.
if you look at this one, then this is A. So this is A. So A to B, if I draw A to B, so A to this is A.
Yes, sir.
Draw this is A. Let us pick one dark color. This is A, right?
Yes, sir.
So A to let us take this as X.
Yes,
Okay,
sir.
A to X
1.
1. Then X to A. That means again.
We can remove that, no, sir.
No, this potential is different now. Here
Yes, sir. Yes.
one capacitor is there.
Yes, sir.
Okay, now here capacitor is not there, so potentials are same here. So we can
Same. Yes.
remove
Yes.
this. But here this is different now. Here you got capacitor here.
Yes,
Okay,
sir.
then X to B, X to B. Okay,
2.
and then you have
2.
A to B, A to B.
Yes, sir.
So this is C, this is C, this is C, and this is C. So you just calculate the effective. So C and C, this will become
Parallel.
parallel. So this is 2C.
Parallel.
2C and C series. So
Yes,
this
sir.
is 2C into C by
2C by.
3C.
Yes,
That
sir.
is 2C by 3. So
Yes, sir.
2C by 3 and C are in
Parallel.
parallel. So that is 2C by 3 plus C.
Plus C.
That is equal to, because then it will become parallel.
5.
So 2C
5C by.
plus 3C by 3.
Yes, sir.
5C by
5C by 3.
3.
Yes, sir.
C effective.
Yes,
Equivalent
sir.
is 5C by 3.
3.
Okay.
Yes, sir.
Now, right. There is another circuit which is called as Wheatstone based circuits. Okay,
Yes,
let's
sir.
see what is Wheatstone based circuits. Wheatstone bridge based circuit. So Wheatstone bridge based circuit is something like this. This is capacitor C1.
Yes, sir.
This is C1. This is C2. and then you have uh, another circuit here, another capacitor here,
Yes.
and here you have one capacitor. You connect like this, and you connect like this. Okay, so this we call it as Wheatstone bridge base
Mm,
circuit. Now let us take this as A and this as B.
B.
Okay. Now this is C1, this is C2, this is C2, and let us take this as already I wrote this as C2, right?
C2. Yes.
Okay, C2 means here I should write as C3, and this is
C4. C.
C4, and this
Yes.
is
C5.
C5.
5.
Now, now I'll say the bridge is balanced when C1 by C1 by C2 is equal to C3 by C4.
C4. Yes, sir.
When this condition is satisfied, then I will say the bridge is balanced.
Yes, sir.
Bridge is balanced. When I say the bridge is balanced, then I'm going
C5.
to remove this C5,
C.
and then I
Yes,
will
sir.
treat that these two as in series.
Mm-hmm. Series.
These two are in series. So I will calculate the effective, and then I will add them because the effective will be parallel,
Yes, sir.
right?
Yes, sir.
So C of EAB will become, now for these two, effective will be C1 C2 by C1 plus C2, and effective of these two is C3 C4 by C1 plus C2,
1, 2, 3.
and
Oh,
those
C.
two,
C plus.
this and this are in parallel, so I will write plus. Okay, that is when bridge is balanced. When bridge is balanced, you can remove this one. When this condition is satisfied, then only you can remove that C5.
Yes, sir.
Okay,
Yes, sir.
right. Next one is infinite chain of capacitors. Okay,
Yes, sir.
infinite chain of capacitors. So when you have an infinite chain of capacitors, let's say you have this is C1, this is
C2.
C2.
Yes, sir.
Okay, then again you have C1, and this is
C2.
C2. Again you have C1, ladders, infinite ladder.
Yes, sir.
You have C2. So on like that. Okay, up to infinity. Okay,
Yes, sir.
so basically we solve like this. The effective I will take it as C. So if I one chain is added to it, then also its effective is then also the capacitance won't change. So I will take here as C, and then I will calculate the effective.
Yes,
Okay,
sir.
so I will consider this as C. Okay,
Yes, sir.
let us take that CR. Okay, this is CR effective is equal to C1, and this, see, one ladder, one part, if you just add to infinity, its value is not going to change,
Yes,
right?
sir. Yes, sir.
So I will consider that one here, this infinite chain also. I will consider that as CR.
Yes, sir.
Okay, so
Yes. Parallel.
these two are in parallel. So
Yes, sir.
C2 plus
Plus,
R,
uh,
and this is in series with this one. So
yes,
by C1
C1 plus
plus C2 plus
R.
C effective CR.
Yes, sir.
Okay, and then I will
Yes,
multiply here, and then I will just simplify this one. Okay, so now this might take time when you are doing in real time for the exam. So I will give you a shortcut formula for this.
yes,
Okay,
sir.
C is equal to the effective capacitance is equal to, remember this one, C2 by 2. Where is C2? This C2. This is C2. Okay,
Yes, sir.
C2 by 2 bracket start. You put a square root of it, and then you write 1 plus 4 into C1 by C2
Yes, sir.
minus 1.
Yes, sir.
Just if you substitute, then you will get the answer. So C1, C2. Generally, it will be like 1, 2 or something like that. Okay. So very
Yes,
easy to calculate. Directly you will get the answer.
yes, sir.
C is equal to C2 by 2 into root of 1
1 plus
plus 4 C1 by C2 minus
1.
1.
Yes, sir.
Okay. Very
Yes,
easy formula based.
yes, sir.
That is infinite chain, but this has to
Yes,
be like this only.
yes, sir.
Okay. Yeah. Now, compound dielectrics. One more concept I would like to discuss here is compound dielectrics. Compound dielectrics. In compound dielectrics, what I'm going to do is, say this, these two are the plates,
Yes, sir.
and this one dielectric is different,
Yes, sir.
and this dielectric is different. Okay, let us take
Yes,
this as K1 and this as K2.
K2.
This K1 and other one is K2.
K2. Yes, sir.
Okay, now here what you can do, see, this one is nothing like this. We can write it like, okay, this is capacitor C1, this is capacitor C2
C2.
connected in
Series.
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 Okay, now
Yes,
C1 is equal to, see how I am writing, C1 is equal to epsilon naught, okay, K1 into epsilon naught A by, now here this is half of the distance, so this is D by 2.
yes, sir.
Then C2 is equal to K2 into
K2 not
epsilon naught A by D
D
by
by
2.
2. 2. Yes, sir.
Okay, just substitute here in the formula. C is equal to C1 C2 by
C1 plus C2.
C1 plus C2.
Yes, sir.
Now, if you just simplify this one, you will get C equivalent is equal to C equivalent. If I just substitute these values, then I will get C equivalent is equal to 2 K1 K2 by
K1 plus K2.
K1 plus K2
K2. Yes, sir.
into epsilon naught A by D.
D.
Okay. Now
Yes,
here
sir.
this K equivalent into epsilon naught A by D,
D
which is equal to C equivalent. So
equivalent.
what is that K equivalent? That K equivalent is nothing but 2 K1
K2
K2
by
by K1
K1 plus
plus
K2.
K2.
K2. Yes, sir.
Okay, that's compound dielectric.
Yes, sir.
Okay. Now, the other one is, let's say if we take like this. Okay, now these two are plates, and you have here, here this is K1. Okay,
Yes, sir.
and here it is K2. Then this is area is A by 2.
A by 2. Yes, sir.
D is same.
Yes, sir.
Okay. Now here this looks like they were parallel. Okay.
Yes, sir.
C1 and
C2.
C2. So C1 is equal to K1 epsilon naught A by
A by
2D.
2D. D. Yes,
C2
sir.
is equal to K2 epsilon naught A by
2D
2D. Then C effective is equal to C1 plus
plus
C2.
C2.
So that is K1 plus
A1
K2
plus
by 2 into epsilon naught A
epsilon naught
by
A
D
by D. Yes, sir.
is equal to C effective.
Yes, sir.
So C effective is equal to K effective into epsilon naught A by
A by D.
D.
Yes,
Then
sir.
K effective is equal to K1 plus
K2
K2
by
by
2.
2.
Yes, sir.
Okay. Now,
Yes, sir.
if you take bit more complex than this one, let's take one. Yeah. So this is C3 K3. Okay.
Yes, sir.
And here you have two. No, this is K1 C1. Okay.
Yes, sir.
And here you have
C2
K2.
K. C2. Yes, sir.
Now, first you have to calculate these two are in. So this circuit is like
Series.
this.
Yes,
Okay,
sir.
this is C3. C1 and C2 are in.
C2.
C1
Series.
and C2 are in series, and then C3.
Parallel.
So here C effective is equal to, for these two, C1 C2 by C1 plus
C1 plus 2.
C2, and that is parallel with C3.
C3. Yes, sir.
Okay.
Yes, sir.
Now you know how to write this value. C1 is
Yes,
equal to K1 epsilon naught A by D by 2.
2. Yes, sir.
C2 is equal to K2
A2
epsilon
epsilon
naught
naught is to
A by D by 2.
2. Yes, sir.
C3 is equal to K3 epsilon
So
naught
epsilon naught
A.
A by
No,
2D.
A by 2D.
2D. Yes, sir.
I think here also the area is A by 2, right? So here A by 2 is there. So this 2 gets cancelled. A by 2
Yes,
is there. This 2 gets cancelled.
yes, sir.
So this will become K1 epsilon naught A by D. C2 will become K2 epsilon naught A by D. C3 will become K3 epsilon naught A by 2D.
2D. Yes, sir.
Okay. You just have to substitute here.
Yes, sir.
Then the final K equivalent, how much you will get is K3 by 2 plus K1 K2 by K1 plus
K2.
K2.
Yes, sir.
Okay.
Yes, sir.